Okay, so this is Junior Roberts. We're on part 5 of our logic gate series. I'm actually doing a complete series in which I'll be looking at logic gates. So I've done videos 1 to 4 already. I will place a link down in the description and also in the top of this video so you can go ahead and check out the entire series. So let's get on with part 5 of our series. Okay, so some learning objectives that we'll be looking at in this video. So we'll be defining the OR gate. We'll derive the truth table for the OR gate, and we'll also formulate a Boolean expression for the OR gate. So as usual, we first need to actually determine what is the OR gate. So the OR gate is a type of logic gate that accepts two logical values as input and produces a single logical value as output. And we can take a look at the symbol for the OR gate. So as it is, we have a curve at its input, and we also have a curve at its output. So if you look closely, you might see that the OR gate kind of resembles those spaceship in some of those video games that you probably play in your free time. So this is a symbol for the OR gate. We need to be completely aware of its symbol. So the function of the OR gate is similar to that of us summing the logical values that are located at its input. And when we actually take a closer look at the truth table, we will see this function coming into play. So we know that each logic gate has its own truth table and Boolean expression, and we're first going to be looking at the truth table for the OR gate. So just a refresher, a truth table is a table which shows the possible inputs and output for a logic gate. So let's take a look at the truth table for the OR gate. Again, because the OR gate takes in two input, we're going to have input A and input B, and we're going to start by filling out input B with a 0, alternate to a 1, then we'll alternate to a 0, and then we'll continue on. So let me just go ahead right now and fill out each column. So we're going to start again with this column here labeled input B. So start with a 0, and then we'll alternate to a 1. Alright, then we'll alternate to a 0, and then we're going to alternate back to a 1. And then starting with, to fill out for our input A, we're going to start with 0, keep our 0, alternate, and then we're going to keep our 1. Now, earlier on in the video, I said that the OR gate function, similar to us actually summing the bits or summing the values that are at the input for the OR gate. So if we look at the first row here, when we have 0 and 0, if we were to take the sum of 0 plus 0, we would get 0. Right? In this case, if we take 0 plus 1, we will get 1. Now if we take 1 plus 0, we will get 1. Now here, if we take 1 plus 1, we will get 2. Right? But because we're dealing with binary and we can only have 1 or 0, what we'll have is we'll have a 1 and a carry. But that's outside the scope of this video. But essentially what will happen is that when we have 1 and 1 at the input, we will get a 1 for the OR gate. And that's our truth table for the OR gate. So what we see is that once we have a 1, once we have a single 1, in this case here, or in this case, we will get a 1. Or once we have both 1s present at the input, we will get a 1. So anytime we have a 1 at the input of our OR gate, we will get a 1 coming at the output. So let's quickly look at the Boolean expression for the OR gate. So the OR gate Boolean expression is given as our output X is equal to A or B. So if we have a 1 at A, we'll get a 1 at our output. If we have a 1 at B, we'll get a 1 at the output. If we have both 1 at A and B, we will still get a 1 at our output. So that's the Boolean expression for our OR gate. Now let's quickly wrap everything together. So what we have learned so far is that the OR gate is a type of logic gate that accepts 2 logical input and produces a single logical output. The OR gate produces a logical 1 at its output when a logical 1 is present at either one or both of its input. And the Boolean expression which governs the function of the OR gate is given as x equal a or b. Alright, so again, this was Junior Roberts from realjuniorroberts.com. If this video was helpful, please hit the like button and consider subscribing so you'll be updated whenever I post new videos. Also, if you think others will benefit, please hit the share button. Share this out on social media so others can actually get a chance to benefit. Leave a comment below if you have any questions, and thank you for watching.